quotient of powers. So we're going to build on what we learned yesterday. Yesterday we learned product of powers. Today we'll move on to quotient, which is dividing. Quotient of powers, if we're looking at x to the 7th divided by x to the 3rd. Remember, x to the 7th, what that means is we're repeating x 7 times. So x times x times x times x 7 times divided by x to the 3rd. So remember when we're dividing, cancel terms out. So have an x up top and an x on bottom, and cancel those out. And keep going. One up top, one on that, one I'm left with is x to the 4th. You can see that is just taking 7 minus 3. As long as my base is the same, remember the base is the number that's being repeated. So in words, to divide powers having the same base, subtract the exponents. Algebraically, you can put it this way, I have x to the m divided by x to the n. That equals x to the m minus n. Let's get some examples. I have x to the 13th divided by x to the 9th. Our bases are the same, it's x and x. So x to the 13th divided by x to the 9th, you put 13x's up top, 9x's on the bottom, and subtract. So it's x to the 13 minus 9. 13 minus 9 is 4. So it's x to the 4th. Looking at letter B, I have 2 to the 10th divided by 2 to the 5th. Our bases are the same, it's a 2 and a 2. So I'll take 2 to the 10 minus 5, which equals 2 to the 5th. Letter C, I have negative 3 to the 5th divided by negative 3 to the 2nd. My base is negative 3 both times. So I'm going to have negative 3, keep our base the same, so it has to be in parentheses, to the 5 minus 2, which is 3. So we have negative 3 to the 3rd power. Next we have y to the 8th divided by y to the, remember this is to the 1st. Think of it, if you make 2 as a fraction, y to the 8th divided by y to the 1st. The bases are the same. So I get y to the 8 minus 1 is 7. E, my bases are the same, x to the 8 divided by x to the 7. So x to the 8 minus 7, which is x to the 1st, or just x. Letter F, 7 to the 9th divided by 7 to the 3rd. Our bases are the same, so I get 7 to the 9 minus the 3rd power. 9 minus 3 is 6, so 7 is 6th power. Think of a couple mistakes that are commonly made. Sometimes you might see, if I have 3 to the 8th power divided by 2 to the 8th power, people might say that is 1 to the 8th power. And we don't actually subtract the 3 minus 2. Here our bases aren't the same, so we won't even use this property at all. Another thing that might happen is maybe they want to try adding or subtracting the exponents. So if I have x to the 8th divided by x to the 5th, people might think, oh, that's x to the 13th. That's not correct. We don't add, we subtract the exponents, so that should actually be x to the 3rd. You can try to think of your own mistakes if you've already made some. Another one might be forgetting something to the 1st power. Okay, so let's look at some more examples here. We're going to simplify each expression and leave the answers in exponential form. We have x to the 5th times x to the 6th divided by x to the 2nd. So to think through our rules from yesterday too. We're multiplying here and dividing. So what I like to do is take care of multiplying the top and then simplify the bottom if we can, and then our final step will be dividing. So x to the 5th times x to the 6th. Remember, x to the 5th and x to the 6th. We're going to add those so we get x to the 11th over x to the 2nd. Now we can use our division property. We have x to the 11 minus 2, which is x to the 9. Letter B, multiplying fractions. I get 1 times 1. Here's 1. On the bottom, we have 7 times x squared times x to the 3rd. So we have 7, and then x to the 2 plus 3, because our bases are the same. 2 plus 3 is 5. There's nothing else we can do with that one. Letter C, because are getting much more complex. You guys are fine. You can do this. Okay, and let's just multiply across the top, multiply across the bottom, and then simplify everything at the end. So negative 18 x to the 9th times x to the 7th. We're going to add those. 9 plus 7 is 16. Divided by 3 x to the, we have to the 1st, and to the 3rd is to the 4th. Now we need to look at our division. We need to divide our coefficients. So negative 18 divided by 3, that can be simplified. 3 goes into 3 one time. 3 goes into 18 6 times. So I have negative 6 x to the 16th over x to the 4th, or 1x to the 4th. I can simplify that even further by looking at our x's. So I have negative 6 x to the 16 minus 4, which is negative 6 x to the 12. Letter D. Split it over 1. This is a whole number over 1. Multiply across the top to get 1 times x to the 8th is x to the 8th over x to the 5th. Our bases are the same, so I can divide. So I can just subtract my exponents. X to the 8th minus 5, which is x to the 3rd. Letter E. We're going to take 6x to the 12th divided by x to the 7th times 4x. We're going to go ahead and multiply across. I get 6x to the 12th divided by x to the 7th times 4x will be 4. X to the, careful, x to the 1st, there's got to be x to the 7th plus 1 is 8. I'm going to simplify. What number goes into both 6 and 4? 2. 2 goes into 6 3 times. 2 goes into 4 2 times. So I have 3x to the 12th over 2x to the 8th. My bases are the same. Now here I have an x and an x. I can subtract those, so I get 3 over 2. And then x to the 12th minus, or divided by x to the 8th is x to the 12 minus 8, which is going to give me 3x. 12 minus 8 is 4 over 2. The last page on page 12. What is the length of each rectangle? So in this case, yesterday we talked about the area, and if I had this was 3x and this was x squared, we just multiply, and the area of this is 3x times x squared is 3x to the 3rd. Okay, so today we're going to reverse that. I already know that this is 27 x to the 9th. So 3x to the 4th times what length gives me that? Essentially, that's just division. I'm going to take 27, our area, 27x to the 9th, divided by 3x to the 4th. 3 goes into 3 one time. 3 goes into 27 9 times. x to the 9 over x to the 4. My base here is the same, so I can subtract and get 9 x to the 9 minus 4, which is 9x to the 5th. So what I'm saying there is that the length of my rectangle is 9x to the 5th power. And I can check that. 3 times 9 gives me 27. Oops. X to the 4th times x to the 5th gives me x to the 9th. So I know that that's correct. Last one, I know that the area is 48x to the 12th. So I'm thinking 6x to the 6th times what gives me that? That's a division problem. 48x to the 12th divided by 6x to the 6th. 6 goes into 6 one time. 6 goes into 48 8 times. So I have 8x to the 12th divided by x to the 6th, which will give me 8x to the 12 minus 6, which is 8x to the 6th. Again, I can check that by multiplying 6 times 8 is 48, x to the 6th times x to the 6th. We add those and get x to the 12th. So I know that I'm right there. Alright, next up, your homework. You're going to do C.3.2, Quotient of Powers. Worksheet, which is pages 4 and 5 in